Hey everyone, welcome back. In the previous video, we installed Go, set up VS Code, and wrote our first Go program. Today, we are going to take a next step and learn how real Go projects are structured. We'll learn how Go manages project, what go.mod and go.sum actually do, essential Go commands every developer uses, type conversion, operator, if else, switch case, loops. By the end of this video, you will understand enough Go fundamentals to start building actual application. Let's jump in. So we already have a folder set up and a main function. Just to begin, I'll just execute this. Go run main.go. Yeah, it is working as expected. Everything works. But here is a question. As our application grows, how does Go know which project this belongs to, which dependencies we are using, which version of Go we are using? This is where Go modules actually come in. So instead of doing in a single main.go, I want to initialize a complete module. So for that, I'm using a command that is go.mod init go-basics. So I just ran this command and you will notice a file has appeared here. That is go.mod. If I go inside that, at first glance, it looks very simple, but this file is extremely important. Think of it as a blueprint of your project. It tells Go the name of the project, the version, the dependencies required. Before running go.mod init, this was just a folder. After running go.mod init, it becomes a Go project. Right now, our go.mod file is very small. Why? Because our application doesn't use any external packages yet. Let's make a change. Let's install a package that generates unique IDs. So for that, we need to get something. So go get github.com/google/uuid. So I just ran a command and it downloaded me a package and it added that package to my go.mod. Now coming to main.go again, I'll just import that. I just imported and I'm going to remove all this and just give one statement that is so what this is gonna do is it is gonna create a unique ID and print it on the terminal. So I'll now execute this program and I just got a unique ID here. And if you keep on running this, you'll get a different ID every time. Now let's go back again to go.mod. Here we see a difference. Now, do, do you notice something? We never manually edited this file. Go automatically updated it. This file now records every dependency our project needs. If another developer downloads this project, Go knows exactly what package must be installed. You all have noticed another file has appeared, that is go.sum. This file confuses many beginners. Here is a simplest explanation. Think of it like this. So go.mod is something what packages we need. go.sum is a verification of what was downloaded. So when Go downloads a package, it stores cryptographic checksum inside go.sum. Later, Go can verify that nobody has modified those packages unexpectedly. So go.mod tracks dependencies, go.sum verifies dependencies. You usually never edit either of this file manually. Go handles them for you. And now let's come back and remove the UUID package. I'll just remove this line from the import and I'll just add hello world. Very simple print statement. And now let me run a command go mod tidy. I'll explain this. What does this command do? Now I just ran. Now I'll go back to go mode again. Now, do you notice something? The unused dependency has been removed. So what does go mod tidy actually do? It removes unused packages, adds missing packages, cleans up our dependency files. Whenever a dependency issue occurs, the first command that any developers should run is go mod tidy. And one more useful command is go mod download. Actually, this downloads all the dependencies which are listed in go mod. You may not use this every day, but it is very common in Docker builds, CI/CD pipelines, and automated deployment. Think of it as download everything my project needs. And now let's talk about formatting. I'll come back to main.co. I just wrote this simple program and I'll remove the spaces and I'll run this. Now I got the same output. Technically it works, but it reads, it is very difficult to read. So now I run a command that is go fmt, that is formatting. See how magically Go just changed the formatting and it is clean, nice, and very easy to understand. One thing developers love about Go is that everyone uses the same formatting styles. No debates, no arguments. Just run, go format. Another command you'll often hear about is go wet. Let's create something suspicious in this piece of code and then I'll explain why we need. So I'll just remove this and add %d and then a hello string. So if I run this code, I got a %d and I got a hello. I didn't get any errors while executing this piece of code. But if I run as go wet, so I got a warning here. And from the line 8, fmt println call has possible printf formatting directive %d. So what this is actually trying to tell me, Go warns us about potential problems. Think of go wet as a code reviewer that helps catch mistakes early. This is very simple mistake and sometimes we may ignore it because our code is working. Yeah, running this command will help us. Let's quickly recap whatever we have learned so far. So go mod init creates go group project. Go.mod is a file that stores project information and dependencies. Go.sum verifies downloadable dependencies. Go mod tidy cleans dependency files. Go mod download downloads project dependencies. Go format formats the code. Go wet finds suspicious code. Now that we understood the project structure, let's move on to the language itself. Go is strongly typed language. That means Go does not automatically convert data types. Let's say, for example, I created a variable named age and assigned a value as 25. And then I am creating a var that is salary and giving that data type as float 64. Now, in the next line, I'm going to assign salary is equal to the age. And then I'm just trying to print the salary. Let me run it. So here I'm not getting any error. But if I remove this piece, I'll just remove, and if I run, so it says cannot use age variable of type int as float value in assignment. So this produces an error because age is an integer and salary is a float. Go wants us to be explicit. So the correct version is the one which came earlier, that is float age. So whichever data type we want it to be converted to, we'll just write that and then place the variable what we want to convert inside the braces. So if I run the code again, we don't see any errors. So now one more thing I'll do. Now I converted integer to float. A second example I'll do as float to integer. That is where price float 64 is equal to 99.9 and where price int I'll write is equal to int of price. So I'll add one more println that is price int. So first line prints the salary, second line prints the price. So now in the price float value I have assigned as 99.99, but actually while printing it has printed 99. Notice that Go removes the decimal portion. It does not round the value. So going ahead, next is string to integer. Suppose you want to convert from string to integer. So for that we need to import a package, that is string conversion package. I'll just remove this piece of code completely and start with a fresh example. That is, I'll just have a number and then I'm not explaining this part, that will be covered little later. So I am calling that string conversion dot a to I and I'm passing a string. This is a string which looks like a number. So post conversion, let's see what it will print. So let me quickly run this. So now we are getting a output as 0 because this is a invalid string. Now I'll just remove this spaces and try to rerun again. Yeah. Now that integer, sorry, the string is converted to the integer. Suppose if I want to convert an integer to a string, what I should do? So I can first create a variable which holds the integer and then a string variable which is actually calling string conversion I to a and a variable which I want to change. Now I'm going to print that. Yeah, now I have a piece of code. Let me run that. Now it is printing 25. We'll learn about this error handling in little later stage. I'll not go into deep dive that. And the next concept is on operators. So this operators helps in performing calculations and comparisons. So basically there are three types. First is arithmetic. Next is comparison. Next is logical. We'll see the example one by one. So arithmetic. I'll just create two variables. One is A, one is B, and perform all the basic arithmetic operations on these two variables. So I'm just gonna write as A plus B and copy the same piece of line and paste it again, 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 and again, and just gonna change the operators. Addition I have done, subtraction, multiplication, division, and the remainder. Now let me run this. Before running, I'll just clear everything so it will be clear. Yeah. So yeah, Go is next level at catching this kind of things. So I've imported a string conversion, but I have not used it. So I'm just gonna remove it and rerun. Yeah. First output is 15. That is A plus B. 10 plus 5 is 15. A minus B is 5. A into B is 50. A divided B, that is 10 by 5. That is 2. Actual division. And A percentage B is actually gives us the reminder when we do any division operations. So since 5 completely uh, is a multiple of 10 is a multiple of 5, so we are not getting any reminder. So this is all about arithmetic operators. Now I'll just note this part and move to comparison operator. So I'll use the same A and B example to do this as well. So println and A greater than B. I'll just copy this and paste it for another 3 times. A greater than B, A less than B, A is equal to B, and A is not equal to B. This is going to return as whether the comparison is true or false. Let me run this. So yeah, first expression is A is greater than B. So 10 is greater than 5. Yes, that is true. And second expression, A less than B. No, 10 is not less than B. Not less than 5. That is false. A is equal to B. 10 is not equal to 5. So that is false. A is not equal to B. 10 is not equal to 5. Yes, that is true. So this is the output we got. This is about the comparison operator. Now let's move to the logical operator. So I'm just going to create one more variable, that is age. Age I am going to keep as 20 and one more variable as has license. And that I am going to make as true. Now I am going to write a simple comparison logical operator where age is greater than or equal to 10, age is greater than or equal to 18, and has license. So in this first condition it will check is the age greater than 18. Yes, age is 20, so it is greater than 18. And is an operator which will actually tell that both the conditions has to be true to get an output as true. So has license that I have made as true. So obviously it will be true. So true and true gives us a true. Let's run it and check. Yeah, we got an output as true. Suppose if I make this same age as 16, so age is not greater than 18 and has license, I'll make it as false. So false and false will give us false. Yes, we got a false. Similar to this, we also have this is OR operator. What this does is if one of the expression is true, it will return true. But in and both the expression has to be true or both the expression has to be if even if one of the expression is false, it will return false. So both the expression has to be true to get the final result as true. But in R, if one of the expression is true, you'll get a final result as true. And there is one more operator that is not. Not is something like the opposite. If it is true, it not of true is false, not of false is true. So I'll just write a short summary here. You can explore on this as an exercise. So I'll write here one of the expression is true, output is true, not of true is false, and vice versa. This is AND operator. Both the expression has to be true to get the result as true. Yeah, sorry. Yeah, I hope this piece of code is clear. Going ahead, now you know constant variables, data types, operators. Now we'll see if else part. So in the if else, it is like condition. So let's say for example, if my score is greater than 90, then we'll classify that as grade A. Or else, if my score is greater than 80, I'll classify it as grade B. If below that, grade C. This is very simple and naive example. To have much more simpler example, if a person age is greater than 18, we call them adult, or else we call them minor. How to write and express it in a code? For that, we need some conditional statements that we get from if else. Let me quickly write a short program for that. I just have a age that is 20. I'll write the condition. For that, if is a keyword followed by what condition you want to check. Age is greater than or equal to 18. Then what? fmt dot print ln adult. If it is not greater than 18, then fmt dot print ln minor. So now the age is greater than 18. Have to get a result that is adult. Let me clear the terminal. Run the code again. Now I'm getting a result that is adult. Now if I enter as 15, now I'm expecting to get a minor. Yeah, I got as minor. Suppose it is not just two condition. You have a condition more than two. For that, you can have if else if ladder kind of thing. The score example, which I told earlier. Score is equal to 99, I'll put just like that. If score is greater than or equal to 90, I'll give grade A. Else if score is greater than or equal to 80, I'll give grade B. And else if score is greater than or equal to let's say 50, I'll say grade C. Else I'll put them under fail. This is just an example, not the actual condition. So now my score is 99. I have to get a grade A. Let's run this and check. Yeah, I got a grade A. Now I'll change it to, let's say, 85. I have to get a grade B. I got a grade B. So how this actually works? First, it will come here and it will check, is the score greater than 90? If true, it will come inside this, execute this piece of code and come out. It will not go and check inside this. Suppose if that this condition is false, then it will look for else if. If this condition is also false, then it will come here. If this condition is also false, then it will come here. If in between anyone succeeds, it will not go and execute the next statement again. That's the beauty of this conditional statements. Suppose, for example, you are building an application where you want to authenticate an user and only authenticated users you want to be inside your application. You can just block them by using if else conditions. That is as simple as it is. That's why these basic concepts are very, very important in any programming languages. So yeah, 85 is done. I'll enter a score that is way less than 50. Let's say 32. I know 32 is not a bad score, but yeah, we'll get a condition that is fail. So this is all about if else. Now you can't keep on expanding the same condition again and again. If you're let's say if you want to say write some 10-15 conditions, then we can use switch cases, which actually become handy when you are evaluating something based on only one or two variables. So let's say for example today. So today is Monday, and based on the day I want to say whether I should start working or weekend is near. So for that I'll write a switch case. So for that I need a keyword that is switch, and on top of which variable I want to execute this switch case. So that is on top of day variable, and inside that what are my cases. So case 1. So if the day variable happens to hold Monday value, then I want to print start working. And if the case happens to be Friday, I want to print weekend is here. And if none of this matches, it is just a normal day, and that is default. Yeah. Now I have assigned a value that is Monday, So it will come here and we have a switch condition. It will go inside, check for which case matches. It checks Monday. Okay, Monday is matching. So I'll print this and I'll not look at the rest of the things. Let's execute and see. Yeah, start working because it is Monday. Now I'll update it as Friday. So what we are expecting? We are expecting to see an output. Weekend is here. Let's run this and see. Yeah, we got an output which says, yes, weekend is here. I will add Wednesday. So run this again. And it's just a normal day. Weekend is still 2 days away. Yeah. So I just gave an example which has only two conditions and one default. And suppose if you're running a very big query or something, like conditions, you can definitely make use of switch if you have one variable and depending on that value you want to make some decisions, you want to take some actions, you can definitely use this. So beauty of switch is it is very clean, easy to understand, and much cleaner compared to if else statement. So just add a case, what case you want and what action you want to take. I just added a print lines here. If you want to take some other actions, you can add that here as a code. And in other languages, if you have uh, explored that, in switch usually you need to add break. Without break, it will continue executing below code as well. But in Go, no need to do that. It will just execute only that piece of code, whichever is true for that case. If not, it will come and falls back to default cases only. So now we know about the switch cases. Let's go one step ahead and learn about loops. Sometimes we need to repeat some tasks. For that, we can use a simple keyword that is for and run loops as per our wish. So for is a keyword and I need to initialize a variable, let's say I, and I'm initializing it with 1. And then I'm going to give a condition until what value of I this has to run. So I'll say 10. And how I want to increment this particular variable. I want to increment it by 1. So I'm just adding plus plus. Inside this, I want to do some action in this 10 iterations. What I am going to do? Just a simple println. I'm just going to print the I, whatever that value holds. Now let me clear this terminal and run this program. So here the program has run for 10 iterations. This particular for loop has done 10 iterations. And the first time when it ran, I value was 1. And it checked the condition. Is I less than 10 or equal to 10? Yes, it is less than 10. So it went ahead and executed this. So it printed 1. Then it came back and it updated I plus plus. So I plus plus is nothing but incrementing I by 1. So 1 plus 1 is 2. Again same. 2 is less than or equal to 10? Yes. So print. This happened till I became 10. When I became 10 and it printed this value, it went ahead and updated it by 1. And then I became 11. So again this condition is checked. Is 11 less than or equal to 10? No, it's not less than or equal to 10. So we came out of the loop. This is very simple for loop. Suppose if you want to run a while loop and go style go while loop is slightly different from other languages. In the for only you can run the while loop. I will initialize the variable that is count is equal to 1 and I'll update here as count greater than 5. Sorry, count less than or equal to 5. and then I'll make count plus plus. So what actually is happening here? Count is a variable which is initialized with the value 1, and my for loop is checking, is the count value less than or equal to 5? Yes, it is. So it will print that value and increment it by 1. It repeats. When 5 reaches the value, count reaches the value 5, it will print and then again it increment. Then count becomes 6. This condition fails and we come out of this loop. So I have to see numbers printed from 1 to 5. Yeah, here is that. This is how a while loop is created using for keyword in Go. So instead of putting everything in one line, the initialization, the condition, and the increment, instead of putting everything under one line in front of for, we initialize it outside. We add the condition next to for and we increment it after printing it. Though flow of execution is same, but visually the representation is very different. That's how it is. And we have a loop that can run in ranges also, which I'll not be covering now. I'll be covering once we do arrays. So whatever you have learned so far is Go modules, go mod, go sum, go mod tidy, go mod download, go format, go vet, type conversion, operators, if else, switch, and basic loops. In the next video, we'll learn functions, parameters, return values, multiple returns, and anonymous functions, which are some of the most powerful features in Go. So if you have enjoyed this session and if you have learned something from this session, please do like and subscribe to this channel. It will motivate me a lot to more to do more such type of contents. I might have missed something or I might have done some pronunciation mistake. Please bear with me. It's my initial days. Slowly I try to improve myself. And if you have stayed till here, thank you so much for watching. Until next time, see you all.